Thank you, Davide. So hello, everybody. My name is Shahar Feldman, and also from Semtech. I lead the product marketing team for Semtech for the Wireless IC product line. And today I will introduce the Swiss Army knife of IoT, or how LoRa Plus enables AI applications. So by now, you guys are probably experts. You have listened to so many keynote speeches along the day, and you've probably seen a lot of great opportunities for the AI revolution in IoT connectivity. Here we can see some of the numbers. I'm sure there are plenty others that are showing tremendous growth opportunity for edge AI and IoT. You can see also a lot of different applications, from smart manufacturing to cities to commercial to smart agriculture, many different use cases, all using edge AI in different capabilities, from predictive maintenance to audio classification, image recognition, and so forth and so on. So this introduces a huge opportunity. However, it also introduces some challenges. If in the past, traditional IoT sensors would be sending a couple of bytes for audio or for sensing, for temperature information, today AI applications demand rich data. And this is true for uplink. If you're looking into audio clips, anywhere in between tens to hundreds of kilobytes, or images, 500 kilobytes even. Also, on the downlink side, you would have to train your AI models, or it support a firmware update. So these would all be applications that would require bidirectional high data rate. This creates a connectivity gap. So traditionally, LoRa has been the ultimate solution to support IoT applications, thanks to its low power, long range, and decent data rates that were supported up to 50 kilobit per second. Today, when we're looking into AI, we're seeing that traditional LoRa might be data limited and would not be allowing some of those applications. Cellular IoT has the range, however, it's going to be slightly higher cost and higher power consumption. Wi-Fi and BLE would have, generally speaking, shorter range, so we would be limited in the ability to support those AI. The LoRa Plus that I will introduce today is aiming to address this exact gap, enabling AI at the edge with long range, low power, and higher data rate. So LoRa Plus is the latest addition of Semtech's product family. It joins our LoRa portfolio that is all based on the same foundation of low power, long range, optimized TCO, and it is joining 450 million units that were already deployed in the field. Looking at some of our previous generations, LoRa Core is the name of our gateway chipsets. We have on the side IC4 sensors, LoRa Connect. This is the family of N nodes transceivers, both sub-gigahertz, dual band, or 2.4 gigahertz. The LoRa Edge was a third generation product family that we introduced a few years back that introduced capabilities like location aware, GNSS scanning, Wi-Fi scanning, round trip time of flight, BLE beaconing. And LoRa Plus is the latest addition. This is a multi-PHY transceiver chips that I'm going to be talking in more details right now. In the center of everything is our software library. So this is exactly to David's point before, the LoRa Basics, which is basically the platform that runs the engine behind all these end nodes and gateways, and the unified software platform, which would be our next generation platform that would support more than just LoRaWAN expansion into the other physical layers that we will be showing you. So LR 2021 is the first in the product family, the LoRa Plus product family, and it incorporates the latest Gen 4 IP technology. So aside of providing a state-of-the-art RF performance, this is basically the first time that we are also enabling multi-physical layer support for different low-power wireless connectivity protocols. So we are offering a transceiver, which means that it offers the full flexibility for OEMs to use whichever MCU that they like, load it with any memory footprint, any interface, AI processing, no AI processing, really making it custom to the specific application need. And of course, with the same freedom, OEMs can pick a combination of any low-power wireless solutions out there. Of course, LoRaWAN, LoRa would be a core. However, today we're going to also introduce FLRC, fast long-range communication, and there's going to be, of course, opportunities to host even other third-party protocols like Wireless MBA, Z-Wave, YSUN, and Amazon Sidewalk, and others. So we're pretty excited about the LR2201. We're getting a glimpse view here of the block diagram. So a couple of innovation that we're introducing. This is also a multi-band chipset, which means that we're supporting sub-gigahertz and 2.4 gigahertz ISM, as well as NTN networks, with two dual front solution. And then, of course, there's a wide variety of modem capabilities from LoRa, FLRC, GMSK, 4FSK, OOK, BPSK, et cetera, So again, highly capable. It supports multi-regions with a single SKU, which is very important for basically economy of scales and more logistics perspective. And of course, as we said, multi-PHY support. So, Semtech has been introducing different generations of products over the past decade or so. Since our very first introduction of Gen 1 back in 2013, we introduced a series of improvements with every generation. Gen 1 to Gen 2, we're showing a significant decrease in current consumption. And then from Gen 2 to Gen 3, increased capabilities, more feature sets, as well as the improvements in the link budget, which means range. So if you're thinking about range, we can see an example in between Gen 2 to a Gen 4 solution. We're looking into anywhere between 5 to 6 dB of link budget improvement. That translates into double the range. Or another way to look at it, for the same range, you can basically transmit the same packet in quarter of the time as it would be for a Gen 2 solution. So that means, of course, either in significant improvement in range or significantly improve in energy consumption. Similarly, on the TX card, we've made some improvements. We have a single SKU mentioned that can support all different regions, 868, 915, and we're doing it very effectively across the whole span, from anywhere in 14 dBm, consuming 27 milliamp, all the way up to 22 dBm that would be commonly used in US with 105. Again, kind of breaking the barrier yet once again in terms of both range and power consumption. In addition to that, unique to this generation, we are enabling higher data rate. So, of course, we're pushing the limits on LoRa, supporting 125 kilobit per second, doubling the range, the data rate that we were able to support before. We were also introducing some improvements on our FSK, supporting up to 2 megabit per second, but really, I think one of the highlights for us is the ability to support, for the first time, 2.6 megabit per second. So we talked about the PA, and you can see here the evolution of how we've been supporting the multiple SKUs over time. With Gen 2, we had to use different part numbers to support different regions. With Generation 3, we were able to do it with a single chip, so we had one chip to support all frequencies, however, it required different BOM configuration. For the first time with Gen 4, we have a single BOM, single SKU, really supporting a cost-effective implementation of a single device that can be deployed everywhere, Europe, US, doesn't matter. On the same performance side, cost is also important, and we had taken a couple of innovative approaches here to maintain overall total BOM cost and size. And what you can see here is that we've been able to eliminate the RF switch completely and maintain the full datasheet performance without any switch. That, of course, offers immediate cost saving to the overall total cost solution, as well as the overall size. Similarly, we kept very low, lightweight RF BOM, and we are able to go without the TCXO, or a thermal relief, which is another improvement that we have introduced since Generation 2, thanks to ability to support a better frequency offset tolerance. On the FLRC front, this is one of our key innovations here. So FLRC stands for Fast Long Range Communication. This was first introduced by Semtech back with our Gen 2. However, it was implemented only at 2.4 gigahertz. This is the very first time that we're extending the capabilities of the FLRC all the way from both 2.4 and sub-gigahertz, and we're enabling data rates up to 2.6. And we're doing it, this is on the y-axis we see sensitivity, or kind of corresponding to range, and here this is going to be data rate, both are log scale. And we can see with the same spectral efficiency of LoRa, we're extending it all the way to 2.6 megabit per second with FLRC. And if you're looking at the comparison with the Bluetooth comparable solution, we can see that we're about 8 to 10 dB, so more than double the range. And of course, the better penetration if we're looking into a sub-gigahertz solution. So this brings a very interesting offering to many different low-power wireless solutions out there. So we like to look at this LoRa Plus family almost as the Swiss Army knife of IoT. Why? Because this is a single tool that can be applied to so many different use cases. And this is a transceiver, so it offers the greatest flexibility without really taking any penalty on cost, because all the complexity of the right memory and the AI processing power globally resides on the MCU side. However, the same transceiver can be used on the LoRa one, number one, to offer best-in-class trade-off of energy to power, to range, and of course, it offers, yet again, we took the barrier, raised the barrier up on the resistance to environmental and interference, and really offering full solution for LoRaWAN applications, anywhere from multi-scale, tens of thousands of units, even all the way down to to a very small scale, single hub solution, offering some specific features that I'm not going to get into. However, I'm going to give you some reference to a presentation that will cover some of those benefits tomorrow morning. We have built-in integrated redundancy thanks to our ability to actually switch in between different protocols. So if you think about a meter that can be deployed where LoRaWAN is, and maybe there's LoRaWAN is lost, and you can connect with a wireless M-Bus. Maybe this is lost, we can do an Wi-SUN FSK. Maybe it's lost, you can do Amazon Sidewalk. There's a lot of variety there that is built into these capabilities, and really with no really any trade-off aside of just load the correct stacks onto your MCU. Similarly, we can support legacy devices. So if you have a network that needs to support, for example, a legacy Z-Wave or Zigbee device, the same chipsets having the modulation, the physical modulation capabilities with the correct stack could actually support those. It can enhance coverage. It can connect mesh devices to star networks. It can basically act as a bridge. And lastly, of course, with the high speed rate, we support AI processing at the edge, which is really the focus of this conversation. Lastly here, this is a use case that we've been identifying very recently. We have seen more and more applications utilizing our LoRa in point-to-point applications as a differentiated GPS transmission line or an RTK to really improve and hit the centimeter level accuracy in between robots, for example, cleaning robots or lawnmower robots with their charging stations. So a little bit about availability. So LoRa Plus is sampling for quite some time now. Production is going to be next month. And again, we're definitely inviting you guys who are interested to go see our demos. And if you're interested, please plug sample. We're already approving sample requests in our systems. And it wouldn't be a complete presentation if I wouldn't be able to talk about a couple of more new things. So 2 more things. We have made the announcements today that along with the 2021, which is the spearhead of our LoRa Plus solutions, we're actually introducing already 2 new part numbers that are going to be focused more on the LoRa side, would have the same benefits in terms of IP, range, and power. However, they would be focusing on everything LoRa, first on the dual band with the 2022, and then also on the sub-gigahertz only for the 2012, acting as a great successful products into our Gen 2 product families. So to summarize, our LoRa Plus, we believe, is pretty capable and interesting tool for enabling of the IoT revolution, offering best performance in terms of range to efficiency trade-off, offering, again, the lowest BOM cost and reference design size, thanks to the fact that we no longer need any switch, RF switch, and we are employing a single SKU reference designs. We have plenty of different feature sets that we're going to dive into in another presentation. Some of those are highlighted here, including the 2.6 megabit per second FLRC, the ability to support 4 spreading factors in parallel, improved channel activity detection that we're going to talk, and as well as some improved immunity capabilities that we have embedded there. And of course, LoRa Plus. Plus means that it's LoRa anchored, and then we have the abilities to support different physical air modulations, and we're listing here a couple of those, and I named some others. So I'd like to thank you for your time here. Again, get started with LoRa Plus. You can kind of take a picture of all these good QR codes if you would like to register, get our latest product catalogs, or just register to our LoRa newsletter. We're releasing those monthly to our subscribers, providing a lot of good intel into what we're doing and some of the latest software stacks that we're releasing and other product informations. So, of course, the BO1, you go visit our booth, and ask to see any of our demos. We have a ranging demo, we have image transfer demo, we have walkie-talkie demos, so a lot of good stuff there. And, of course, tomorrow morning at 10 a.m. at the workshop room number 1, we're going to introduce the LoRa Plus workshop, where my colleague Olivier Prévost is going to be diving deep into each one of those different features and show you some of those examples in person. Thank you very much for that.